So you have this diagram for that. Ensure your own line is straight. To draw the diagram, when you're done, let me know.
Done.
Are you done? Okay.
Yes, sir.
So the question says OABC. OABC is a vertical cross-section of a smooth surface. OABC is a vertical cross-section of a smooth surface. Full stop. The straight part OA, the straight part OA has length 2.4 meters. The straight part OA has length 2.4 meters and makes an angle of 50 degrees with the horizontal and makes an angle of 50 degrees with the horizontal. Full stop. A and C are at the same horizontal level. A and C are at the same horizontal level. And B is the lowest point of the cross section. And B is the lowest point of the cross section. Full stop. A particle P of mass 0.8 kilogram, a particle P of mass 0.8 kilogram is released from rest at O. A particle P of mass 0.8 kilogram is released from rest at O and moves on the surface. And moves on the surface. Full stop. P remains in contact with the surface. P remains in the contact with the surface until it leaves the surface at C. Until it leaves the surface at C. Full stop. Find. Colon. Question A. The kinetic energy of P at A. The kinetic energy of P at A. Question B. The speed of P at C. The speed of P at C. Question C. The greatest speed of P is 8 meters per second. The greatest speed of P is 8 meters per second. Full stop. Find the depth of B. Find the depth of B below the horizontal through A and C. Find the depth of B. The depth of B through A, below the horizontal through A and C. Full stop. So do that. Let me see how you're going to fare.
I've gotten the value for the K of P at B of at A, sorry.
Let's wait for Ibukun.
So I've also got an answer for the value of
Okay, what do you get?
Yeah.
What's the kinetic energy at O?
At A.
At A, rather, sorry. Yeah, what do you
I
get?
got 14.7.
Adanik, is that what you obtained?
So I got 19.2.
14.7 is correct. So what's wrong? Kinetic energy at A equals potential energy at O. Do you get that concept?
Yes, sir.
Kinetic energy at A equals potential energy at O. So meaning that I can use this. Now, what is H? That's the bone of contention now. If I use from O now, if you draw a vertical line, don't forget that OA is a straight line. So if you draw a vertical line there, I can find this vertical height H. Opposite over hypotenuse equals sine 50. So what does that mean? H is 2.4 sine 50. So we have mg times 2.4 sine 50. Then you can substitute the mass. What's the mass? 0.8. So 0.8 times 10 times 2.5 sine 50.
So I've gotten the answer.
Okay. So that gives 14.708. So which is going to be 14.7 joule. Kinetic energy at A. So B. Yes. Ibukun, are you done with that?
Yes, sir.
Okay. Is it demanding?
Yes, sir. Sir, I'm not sure of my answer.
Okay.
I didn't get
So what do you get?
6.06.
Correct. 6.06 is correct. Very good. So how did you do it? So that Adaniki can get that better. Okay, let me hear you at first. So I will not preempt you.
Sir, I said kinetic energy at A is equal to kinetic energy at C.
Why?
So I did.
Why? Kinetic energy at C equals kinetic energy at A. Why? Because you are not sure. Because 1, the surface is smooth. 2, A and C are on the same horizontal level.
Yes, that's what I'm.
Do you understand that now? Kinetic energy at C equals kinetic energy at A because 1, the surface is smooth. 2, A and C are on the same horizontal level. Is that clear, Adaniki?
Yes, sir.
So what's the formula for kinetic energy? Half mv squared equals to kinetic energy that we have found here in question A, 14.708. Finish it off from here. So
Yes.
the speed at C will now be what? 6.06 meter per second. Proceed to C, question C.
Supposed to go Sana, sir.
Okay, what's the answer? Yes, Ibukun, what did you get?
So I got 3.2 meters.
Adaniki, what did you get?
0.8.
Both are wrong. Okay, how did you do it, Ibukun?
So I said lots in kinetic energy is called scaling potential energy
Okay, at where?
at A.
At A. No. Don't forget we are looking at B. And B is below the horizontal level. Hope you know.
Yes, sir.
Okay, let me hear from Adaniki.
Yeah, I'm coming, sir. I'm coming.
Potential energy at O.
What? 1.36. I don't know.
1.36, correct. But your 1.36, is it positive or negative? That's why I will catch you now. You are supposed to get it to be negative. Why? Why will it be negative? The question says you find the depth. So it's below the horizontal surface. It must be negative. Hope I'm communicating.
Yes, sir.
Let me call it H prime to distinguish it from the vertical H up there. So you must get it to be negative.
So I also got 1.36.
So negative 1.36. So that shows that it is actually below the level of AC. So if you say Since you have gotten it, I don't know how you have approached it, but you can equivalently say kinetic energy at O, potential energy at O equals kinetic energy at B plus potential energy at B. Don't forget that we said both kinetic energy and potential energy can happen together, which we call total mechanical energy.
Yes, sir.
So that's it. And we have found kinetic energy at O, which is the 14.70. Is that clear?
Yes, sir.
Okay.
Yes, sir.
So that's fine. So H prime is minus 1.3615, which you can say that it is 1.36 depth. Or you want to say 1.36 deep. So that's fine.
But sir, instead of that potential energy at O, I said kinetic energy at E.
Yes. It's the same thing from question A. That's what we have done in question A. We said kinetic energy at A equals potential energy at O. So you are right. That's it. It's the same value. Okay, maybe we should put that, or you say kinetic energy at A equals kinetic energy at B plus potential energy at B. So that's fine. Let's say another one. Number 3 now. Are you ready?
Yes.
A load of mass 160 kilogram is lifted vertically by a crane with constant acceleration. With constant acceleration. The load starts from rest at the point O. After 7 seconds, it passes through the point A with speed 0.5 meters per second. By considering energy by considering energy comma, find the work done by the crane in moving the load from O to A. Full stop. So copy the question and start solving. Have you started solving?
Yes, sir.
Okay.
Yes, sir.
You can see the diagram I've tried to give you.
Okay. Oh,
So this is point O. So the weight of the object will act vertically downwards here.
I've gotten an answer.
Okay, let's wait for Ibukun. Ibukun, are you making progress? Ibukun, are you there? It's like Ibukun is not there.
Oh,
Ibukun,
I got 40 joules.
40.
Yes, sir.
Ibukun, you got 2,800 and what?
30.
Or 820?
830.
No, it should be 320. Okay, what's the distance S you obtained? What do you get as this S?
1.76.
1.76 or 1.75? Hold on, please. Let me quickly